Hi everyone, good evening and welcome to the Constellation Crew, our live Facebook presentation all about the night sky and the constellations you can find in it. I'm joined tonight on camera with Melanie, Nicolette, and Greg, and we have Caleb helping out in the chat. So if you have any questions or comments, answers to our questions that we ask, put them in the chat and we'll help you out there. All right, so we're gonna start with talking about this image that I have up on the screen here. And crew, you're probably pretty familiar with what this is. And if you think you know what this is, you can go ahead and drop your answer in the chat like I mentioned. So what is this a picture of?
It's definitely on Mars.
It is a picture from Mars, yes. And why do you say that? Because it's like red and kind of rocky. It looks almost like parts of Earth though. But it is Mars.
Yeah, but typically when you see something like this, you see it at NASA being worked on. I hardly ever see something like this just in the middle of the field usually, because we know a lot about Earth.
Picking it out for fun.
Yeah.
It is on Mars. So Mars had the Perseverance rover recently land on the surface, and it's been roving around, but it brought this friend called, do you remember?
Ingenuity.
Okay, so there's Perseverance and Ingenuity, and it took Perseverance and Ingenuity to bring this device to Mars. And it recently actually had its first test. And what did it do to test it? What was this designed for?
Fly.
To fly, yeah. So this
It's
is
kind of like a dragonfly with the shadowing on the floor or on the ground. Yeah.
Yeah, well, there's actually a Dragonfly mission by NASA designed, and Melanie, you might know this because we just talked about it yesterday. What's the Dragonfly mission going to explore?
They're going to the moon?
It's going to a moon.
A moon.
A moon with a lot of air around it so that it can fly, a lot of atmosphere. Do you know what one?
Is it Titan?
It is. It's Titan around Saturn. Yeah. So there's a really cool moon around Saturn that has this really thick atmosphere. It's called Titan, and it has lakes of liquid on the surface, but not liquid water, liquid ethane and methane. And it's going to explore that area in space, this Dragonfly mission, by flying around in the atmosphere.
It's so exciting.
Yeah. That's pretty cool. But this is going to fly, or it has flown, on the red planet Mars. So Ingenuity here did its first test flight on April 19th, just a few days ago, and it was successful. So they did another one just yesterday, and it flew for about 60 seconds. They tested if it could go forward and backwards and side to side, if it could go maybe a little bit higher than the time before. But it did successfully fly on the red planet. We had our first flight on another world just last week, which is pretty cool. And again, it can fly because there's an atmosphere. Do you know how thick Mars's atmosphere is compared to Earth's?
I'm guessing thinner.
It is thinner, yeah. Mars is smaller. It's about half the size of our planet. It cooled down more quickly, so it doesn't have, we think anyway, a molten core to really generate some of the protective fields that help, keep our atmosphere intact. And it is smaller, so there's less gravity there to hold on to the air surrounding it. So it is thinner. It's about 1% of Earth's atmosphere as far as density, so it's 100 times thinner than Earth's. But they still were able to fly this on it. And there's something that they sent along with this that doesn't help it fly at all. That's actually underneath its solar panel here. So this is actually a solar panel that helps power it. And underneath this is a little piece of fabric. Have you heard about this, crew? No? It's really cool. On the underside of it, it's kind of about the size of a postage stamp. It's a piece of the muslin fabric from the Wright Flyer, from the first flight here on Earth. It was donated to them. Yeah, and they stitched it on the other underside of this. Well, not like stitched, but like patched it down there.
That's really cool.
Yeah, the Apollo missions actually had a piece of the fabric from the Wright Flyer too. Apollo 11 carried a piece of it, as well as a splinter of wood from the Flyer. But they didn't want to send wood with this device because it would just weigh a little bit too much.
That's
I
really
wonder what the Wright brothers would think about that.
I know. No. Because when did that happen? Over 100 years ago, right? Like 117 years ago. But that seems
crazy.
like a long time, but really, I don't know. It's not that long when we're talking about sending something to another planet and find something on it, in my opinion.
Good progress.
Yeah.
I don't know. I was about to say, in 100 years, we went from the Wright brothers to sending a piece of theirs to like a piece of their machine to a different planet. Like,
Yeah.
I doubt they even dreamed of that.
I know. And their first flight was only like 20 seconds. I don't remember what the first flight for Ingenuity was, but I feel like it was a little bit more than that. I think maybe 30 seconds. The second flight was about 60 seconds. Of course, technology has increased quite a bit, but yeah.
Just a little bit, yeah.
Yeah. So Mars's atmosphere is thinner than ours. It's 100 times thinner. But it does have an atmosphere, and it's mostly carbon dioxide. And just a few days ago, the Mars rover did something else that was amazing. And it has to do with this device here. So this is actually being put together here on Earth back before the Mars rover went and landed, of course, on the Red Planet. It was constructed here. We sent it over in a rocket ship. But this is it being built in a laboratory here on Earth, of course. So there's this device. It's about the size of a toaster. A large one, it looks like. That was put into the rover. And this did something really special with the atmosphere on Mars. Did anyone hear about what it did? I think this is in some ways like just as cool, if not a little bit cooler, than the flight on Mars.
No idea.
Okay, so it has to do with the atmosphere, and the Martian atmosphere is about, it's mostly carbon dioxide. But we can't breathe carbon dioxide, right? What can we breathe?
oxygen.
Oxygen. So this device is actually turning carbon dioxide into oxygen that we could one day maybe breathe if we were to go there with one of these devices. So we wouldn't have to bring all the oxygen with us. Carbon dioxide is all around planet Mars. With devices like this, we could turn that into oxygen, which we could breathe and then also use for fuel for rockets. And so this did its first test, and it demonstrated that it could turn carbon dioxide into oxygen. It did that, when it did that? On the 20th, so just a couple days ago.
Do you know how efficient it is at doing that?
I don't know the efficiency. I know it takes a lot of electricity, and there's not a lot of energy sources on Mars. I mean, there's solar power, but it would take, I read that it would take like a 200 square meter solar farm panel arrangement to power something that could sustain life.
Mm-hmm.
And that's just kind of impractical. So they're thinking about using nuclear power instead, which is what the Perseverance rover uses. It uses an RTG, basically the decay of plutonium-238. It decays, it creates heat, and it powers the rover. That maybe like plutonium or other nuclear power could support the electricity needs, the power demand for this type of device.
Like a little mechanical house plant.
Yeah.
I love that.
This is called MOXIE, by the way. It's MOXIE, which I think is cool. It's short for, or like an acronym basically, for Mars Oxygen In Situ Resource Utilization Experiment, which is just a fancy way of saying that it's going to use the carbon dioxide that's already there on site on Mars to create oxygen. Love it. All right. Back to Earth, back to our sky here in Muncie, Indiana, at Ball State University. We're looking down on campus here, and you can see there's tennis courts there, which is an actual image of the area of campus here. And then we have our horizon where our sky meets the ground, and then everything up from there is basically simulated in our Planetarium software. And we have south there represented by that big S. SW, of course, stands for southwest. And then there's the W there for west, and the sun's up there. It's getting ready to set over in the western horizon for the date that this is set up for. This is set up for the 26th, and we'll explain why in a little bit. But we're going to be focusing on the Big Bear and the Little Bear, Ursa Major and Ursa Minor tonight. And those are in the northern sky. So we're not looking south like what we usually do during this presentation. We're going to look north and speed up time here in our simulation and see the sky this time of the year after sunset when there's no clouds, little light pollution, but basically a clear night. And if you're really familiar with campus, at the very bottom of the video here, or the simulation here, you can see that there's the Cooper Science Complex down there. This is Riverside. Riverside's right here. All right, so the sun's setting. Let's zoom up and see our sky. All right, so here in Muncie, we can see quite a few stars. Even with the light pollution, light from city lights, street lights, houses, and so on. But we can still make shapes out of the stars, and we can see some of the more popular constellations like Ursa Major and Ursa Minor, which we're exploring tonight. And then, of course, inside them are two really popular shapes in the sky. And Melanie's going to help us explore those.
Yeah, so we have sort of a habit of using constellations or other asterisms to find other objects in the night sky. So we're going to use that same sort of strategy tonight. But first off, we're going to have to look for, maybe you've heard of the Little Dipper. And it actually looks exactly how it sounds. It looks sort of like a little spoon. I'll give you a moment to see if you can find it. Like Dana said, we're facing north tonight, so those of you that have a better view of the northern sky, tonight's your night. So we're gonna look for a little spoon shape in the north.
It's really difficult to see with light pollution. In Muncie, we can really only see like 2 bright stars, 3 really, if you look closely. And if you're looking and you're like, okay, well, I see a kind of spoon shape in the sky, you might be looking right here. There's the handle. There's the bowl. It's definitely spoon-shaped. That might be one of the dippers. But it's actually not this one. It's right underneath it. Really, really hard to see. Right around in here. Again, here in Muncie with light pollution, you can really only see a few bright stars in this area. But with our software here, we can bring up some artwork, some lines to help us really make patterns a little bit more visible.
Yeah, and as Dana said, if you can find that dipper a little higher, the Big Dipper is what we call it, then you can use that to find the Little Dipper. And there's also something else important within the Little Dipper. So if you can find the Big Dipper, which you can see there, it looks sort of like it's upside down, right? Like it's pouring something out. And if we use those 2, what we call pointer stars there at the end, and we dump something out of the spoon and follow that down towards the horizon, we hit a sort of bright star. Not especially bright, not especially exciting, but it is special. And this star is the North Star. So again, it's not actually the brightest star in the night sky. It's hardly the brightest. I think it's the 40 something, close to 50th brightest. So it doesn't seem
like
that
the 48th or 49th brightest, depending on if you count the sun or not.
Okay. So yeah, as we follow those 2 pointer stars from the Big Dipper, pour something out of the spoon, we see the Little Dipper and the North Star there. And the North Star is also called Polaris. Maybe you've heard of that. They're the same. And we call it Polaris because it sort of points directly above the North Pole. And the North Pole is special because that's the axis of rotation for the Earth, right? So it's the point in the sky that doesn't appear to move throughout the night. So this is why the North Star is the North Star, right? It's pointing almost directly north relative to the Earth, right? There's no actual directions once you get out into space. It's all relative to us. But we can use this North Star to know where the direction north is. So again, don't look for the brightest star, look for the Big Dipper. You can find the Big Dipper, you can find the Little Dipper, and the North Star. And as the name implies, there's a Big and Little Dipper, but many of you may know that the Big and Little Dipper are not actually constellations. They're what we call asterisms. And it's definitely easier to see than this entire bear up in the sky, right? So following the pattern of the Big and Little Dipper, we have the Big and Little Bear, which is adorable. If you don't see all that, again, you can use the asterisms. We've created them for a reason because they're usually a little bit easier to find. And you should be able to find at least the Big Dipper. Maybe you can see the whole bear if you use your imagination, but you should be able to find the Big Dipper relatively easily because it's actually the 3rd largest constellation, Ursa Major and Ursa Minor, so the Big Bear and the Little Bear.
Yeah, so what are these lines that we just put up here, Mel?
Yeah, so those are the constellation boundaries. So sort of how we map out the sky. And they don't look especially, neat and tidy. We kind of work with what we can come up with in terms of shapes up in the sky.
Yeah, like this one here has some curves to it for the Little Bear Ursa Minor. I wonder if there's curves for any of the other ones. I feel like this might be unique because of the area that it is in. Yeah, so every area in the sky is mapped out. There's no constellations that overlap. This whole area here is the constellation Ursa Minor, and then we have this larger area here, which what you said is the 3rd largest constellation for Ursa Major. Cool. You remember what the largest is?
Is it Virgo?
Virgo is the 2nd largest. We just
Hydra, right?
Yeah, Hydra.
Does each constellation boundary kind of follow along with the pictures, like Ursa Major and Ursa Minor?
Yeah, sometimes, depending on what pictures you choose to draw with it, in our software, some of the illustrations go into other areas of the sky, other constellations. So to make like a full picture, they cheat in our simulation and actually go into other constellation boundaries. Because they're tight boundaries sometimes, and to draw out like the entire creature, yeah. All right, so we shifted our view from north to east here so that we can see this beautiful object right here. I'm sure you're all very familiar with that. That is, of course, our moon. But actually in our simulation here, we're lying quite a bit because the moon is not that big relative to the star patterns like the Big Dipper here in the sky. I actually made the moon 8 times larger so we could see it in better detail in our software. If I made it the correct size, it would look like a very small point, like a star here. In planetariums, like in our planetarium here at Ball State, we make the moon bigger all the time as well in that area, or in that theater. It's like always 4 times larger. Here it's 8 times larger, just so you can see it on your computer screen or your phone screen better. So just keep that in mind for this next part, because we're going to be exploring with Greg here a little tiny patch of the sky that's about 1/10 the size, I think, of the full moon. And this area that was observed was over in the constellation of the Big Bear, right around in here, right, Greg?
Yep. Yeah, so the area that we're talking about, so if you think about the entire sky, the area that we're talking about here is 1/24 millionth of the entire sky. So we're talking about a very, very small portion here relative to the entire sky.
Okay, so we're going to be talking about a really tiny portion of the sky, and to really zoom in and explore small patches of the sky, we use telescopes, right?
Mm-hmm.
And we have great telescopes here on Earth, but we also have telescopes in space, like the Hubble Space Telescope. Did you know actually that it's Hubble's anniversary tomorrow? It's Hubble's 31st.
That's awesome.
Yeah, it's Hubble's 31st anniversary tomorrow. And they just released this really cool picture. I'll try to get it to you all in the chat. But yeah, so we have Hubble orbiting our planet outside of the atmosphere that makes it really difficult to see crisp areas of the sky, or get crisp pictures of the sky, clear pictures of the sky. And with the Hubble Space Telescope, it looked in a really small patch of sky for a very, very long time. For like, what? How many hours? 42 hours or so?
Yeah, they took pictures. They took about 350 different distinct pictures of this really small part of the sky over 10 consecutive days. Now, they didn't do it, every second of every day. But they took these pictures across 10 consecutive days between December 18th and December 28th in 1995. The Hubble was fairly young back in the day.
Yeah. And it got this. Image. So it looked like a dark area in the sky, and I think a lot of people thought it was a waste of time because Hubble was still new. It was really hard to get time on the telescope, and someone with all their time, they were like, well, just look in this really dark area. There's maybe nothing there, but if we collect enough light over those long exposure times, we might be surprised. And they were, because they saw all of this. And what is this?
Yeah, so interestingly enough, this is roughly 3,000 different objects that we're seeing here. And every single, or almost every single one of these objects is in itself an entire galaxy. So we're talking about billions of stars in just the galaxies themselves, and then there are over 3,000 galaxies in this one tiny patch of sky, which is just unbelievable. I mean, when you look at every single one of those little points of light there, to just imagine that you're seeing, each one each one is its whole distinct galaxy is just amazing. Yeah, and if you look in the picture, you can see some of the different types of galaxies that we've been discussing. And so if you've got a really good eye, you can look at that picture and you can see some of the different spiral galaxies, some of the different elliptical galaxies, and then, my favorite, the others, right? The irregular galaxies too. You get you can you get to see all of those different galaxies in this one image. It's just remarkable.
Especially if you weren't expecting to see much of anything.
Yeah. Yeah.
Every little dot, except for the ones with spikes.
Yeah.
Right. Yeah.
Because the ones with spikes are the stars in our own galaxy. Exactly.
Yeah. Anything with a spike, and this next one here too, which is the Hubble Deep Field, which the first one was called the Hubble Deep Field. This one's for the southern hemisphere. So they did the same thing, looking at a different area of the sky. And all of the ones with points here, those are stars within our own galaxy that photobombed this area. They got in the way. But every other little dot, it's a galaxy. Thousands of them.
So
it's cool.
Amazingly enough, it was, the first image wasn't cool enough. They had to 3 years later go ahead and do the same thing just in the southern hemisphere, and we saw the exact same thing, right? We saw thousands of galaxies, which tells us that in space, when we look out into the night sky and you see just these patches of darkness, you don't think anything is there. But when you have a telescope that's out in, that's out in space that can magnify things, they show all of these thousands of galaxies in a place where, like Mel had said, right, you didn't really expect to see any.
Yeah.
It really blows my mind because of how relatively empty space is. So you can even imagine the space in between those individual galaxies. It's crazy.
Yeah, because we're looking in far, like it's not like all of these galaxies are the same distance from us. We're looking really deep into space and seeing quite a bit.
And the really cool thing about the Hubble Deep Field is that it has allowed scientists to study galaxies that are way older than the ones we've been able to previously see. And so when we look at these images, we can see galaxies that are, billions of years old, and kind of see the formation over time, the evolution over time, the different shapes and all that. It's just really remarkable.
Yeah, even more than millions, billions of years old.
Yeah,
really
exactly.
Close to the age of our universe.
Mm-hmm.
And those ones are going to be redder, or pure redder here. And that's an apparent redness because of something called redshift, due to the expansion of our universe. Our universe is expanding, and we see these galaxies that are really distant. The light that is reaching us has been stretched due to that expansion, and longer wavelengths that stretching creates appears red to us. Which is why the James Webb Space Telescope, which is supposed to kind of not replace, the Hubble, because the Hubble's still going to be there, but it's going to just be an upgrade basically out in orbit around our planet. The James Webb Space Telescope is actually going to be looking more into the longer wavelengths to be able to see farther back in time, basically, to explore these distant galaxies.
Just amazing. It's amazing what you can see without the atmosphere and light pollution on Earth, right?
Mm-hmm.
So many pretty colors. Love the colors.
It's the one you can't stop looking at. There's always something new.
Yeah.
It's just the colors.
Oh, it's like those.
Try to play Where's Waldo in that picture.
Yeah. Or like I Spy. If you were in elementary school, you would go to the
There you
library,
go.
and there'd just be tons of toys.
I spy a galaxy.
Yeah. There's actually an activity that we have here that we got from this wonderful network for informal education. It's kind of like a Guess Who game for astronomy. So you have to describe like a nebula, you have to describe a galaxy, and they have to guess what one it is on their little Guess Who game board.
That's really cool.
Yeah, we'll have to bring it out and actually play with it. We haven't done it yet because of COVID. But yeah. But yeah, it looks like the sky looks basically black and white to our eyes, just because we can't collect enough photons basically with our limited sight. But with a camera and with a telescope, we can collect it over a long period of time and actually get color. And so that color that we saw in those images of the galaxies, it's actually there. Space is colorful. All right, so we have our moon here for a reason. It's not a full moon tonight, but in the simulation here, I mentioned earlier that we went forward in time. We're actually showing the sky on April 26th. That's Monday. So Monday night, we have a full moon, and this one's special because it's called the super moon. And what is a super moon? Well, to explain what a super moon is, we have to look at what an average moon is and a micro moon is. And I don't know about you, but there's really not too much of a difference. Like you hear super moon and you're like, it's gonna be huge or something. But really it's not that much bigger than an average moon or even the micro moon. Especially when you're just looking at it in the sky. It might appear slightly larger, slightly more super than it usually is, because the moon is always super. But people get really excited about it because it is a little bit larger in the sky, and for a good reason. Crew,
it's what, 6% bigger, right?
Oh gosh, I don't remember. It's a percentage.
I know it was 15% brighter, but I don't know about bigger.
Oh, see, I thought it was like 30% brighter. I don't know.
Maybe I'm wrong. I guess it depends on.
I'm usually the
Those
one
are
that's
far
wrong,
away.
so I would trust you over me, Mel.
I know that the percentage for it being brighter is larger than the percentage of it being bigger.
Yeah.
Yeah, it's 14% bigger than a micromoon, 7% bigger than an average full moon. So what did you say,
That
Grace?
close. I said 6. I was
Okay.
close. I'm within error bounds, right? Like,
Yeah, but I don't know. I hear 7% bigger, and I'm just like, okay, what does that actually mean? Show me a picture. And so that's why we have this picture here. But yeah, and it's 30% brighter than a micromoon, the supermoon.
yes. Validation.
Yeah. So that's going to happen on Monday night, late Monday night, technically early Tuesday morning, if you go after midnight there, which you should.
Oh, yeah.
Yeah.
Okay. I still think that the supermoon is super because I've always seen it at the perfect time, and if anyone else has seen it at this time, you'll understand what I'm talking about. When it's really close to the horizon, and I mean really close. If you live in the city, it's hard to see unless you have a really nice open area like a lake or flat land. But when it's super close to the horizon, it looks massive. My mom and I have fallen for that trick dozens of times, and it is a trick.
Yeah.
It is a trick. It does not look that massive when it's that close to the horizon.
Yeah, because people like do measurements, they take the pictures, and over the course of a night, they can get the moon, and it is the same size even when it's closer to the horizon as it is when it's up higher in the sky. So that's not what's causing this difference in size here for the supermoon versus the average moon. This is on a longer time scale than just over the course of a night, right? Like this happens once, twice a year, maybe a couple more times if it aligns right. But it's because the orbit of our moon isn't a perfect circle. It's elliptical. So sometimes the moon is closer to our planet than other times just based on where it is in its orbit. And when it's the closest in its orbit to us, and it's full, we call it a supermoon. And we have fancy words for that. So the time when it's closest in its orbit, Prue, do you remember what one that is?
Perigee?
Perigee, yeah.
Perigee, so it's pretty close. And then when it's the farthest in its orbit, we call that what?
Apogee?
Apogee.
Away?
It's
I don't
away.
know.
Yeah, no, that's what I say. Yeah.
Away.
Apogee, so it's away. It's farther away. So if you ever hear like apogee and perigee, it's just meaning that it's either close or it's farther away in its orbit. And this is only like a slight difference, like hundreds of miles, I think. But it does appear a little bit larger in the regulars or in the sky. But I don't know, like I know a lot of people, they go out and they expect a lot. The moon is always super to look at, though. Always go and check it out, but don't expect to be blown away by it. And if you missed this month's, there's one next month. We put that information in the chat for you all.
I think that one's even closer actually, but barely, like less than 100 miles, I think.
It is, yeah, it is closer.
Yeah.
The one next month, which is what, May
26th?
May 26th, the same day. Yeah, it's a Wednesday. All right, so what's actually causing that like trick? That when we see the moon closer to the horizon, it appears larger. This is something referred to as the Ponzo Illusion. And so these kind of converging lines here help us see maybe that one of these moons looks larger than the other. I'll let you be the judge of what one you think is larger than the other. But based on the stuff that's around the moon, really does play a trick on our minds, and we can think that it's larger when it's closer to the horizon, when we have things to compare it to, versus when it's up high in the sky. There's another type of like illusion called, what is it, the Ebbinghaus?
Yep, the Ebbinghaus. I can't remember if it's like the problem or the effect or
Illusion, Ebbinghaus illusion. That is shown here with these circles, right?
Right.
So these circles here, they're actually, the ones in the center here, they're the same size. But with the stuff around it, it makes it look like one is bigger than the other, at least to many people anyway. And again, it just plays a trick on our heads.
It's like those pictures, like the old versus young lady.
Yeah.
Oh, what are those called? There's a name for those, but I don't remember what they're called. But yeah.
And the duck and the rabbit.
Yeah, the duck and the rabbit. Yeah.
Yeah.
Oh, is that like you can see another picture inside of a picture?
Yeah,
Okay.
like you see one or the other.
Mhm.
Yeah. Okay, that makes sense. Those are fun. My favorite ones that most people don't see, and this actually helps with the pictures here for me, is that there are special pictures that force you to use your right and left brain at the same time in order to see the image. If you can't use your right and left brain at the same time, which is possible, you can't see the picture. So
Now I have to know. I'll have to try it after.
they're really fun. Honestly, if you Google it, you'll find some like right and left brain pictures. It's super fun. I love doing that, but just having that, or like some people know how to relax their eyes enough to just make their vision blurry enough, and you can like see that they're the same circles, they're the same size.
Those dual pictures always just used to make me so mad when I was a kid because I could only ever really see one. And everybody
Right.
else was like, oh, I see this. And I was like, no, I absolutely don't.
All right. Sorry, I was getting distracted by the right-left brain pictures that I'm Googling right now because I couldn't wait. But it's making me feel awkward because they're so weird. So I'm gonna go back on track here and let's explore some mythology to wrap things up tonight. So we have our popular cards here that we always bring up at the end of the program to just kind of have us explore what the ancients kind of thought or associated with different stories with the constellations here. And we have Draco back. We explored Draco last semester. So here's Draco. And he shares a card with Ursa Minor, the little bear, which looks like a weasel or squirrel here.
Yeah, it kind of does. Super cute.
I don't know. And those paws too. And it looks less like a Little Dipper here in this depiction. There's a couple
Mhm.
bright stars up here, which is kind of interesting. The Big Dipper is still pretty much the same as what we see it in our sky here. But what's the stories behind these? Because they have these long tails, much longer than Earth bears. And why do sky bears have longer tails than Earth bears, Nicolette?
Well, it ties in with the mythology behind it. Ursa Major definitely has a very strong connection with Greek mythology. However, Ursa Minor, even though they're a pair, in my opinion, since they're Ursa Major and Minor, they're supposed to complement each other based on the names, in my opinion. Ursa Minor is kind of debated on what story it usually follows, but we'll get into that in a second. But Ursa Minor, or Major, is all about Callisto and Zeus. If you guys are familiar with that story, it's a pretty popular one. It's one of my favorites. So Callisto is a nymph, and she made a promise, a very strong promise to the goddess Artemis. And she broke that promise when Zeus and Callisto fell in love and they had a child named Arcas. And because of that, Artemis was very upset. And a lot of people say that Artemis is the one who turned Callisto into a bear. Other people say that it was Hera. For those who are strong into Greek mythology, Hera is Zeus's first or original, however you want to say it. She's the wife of Zeus. And she was so upset by Zeus's betrayal, because they're still together in Greek mythology, that Hera was the one who turned Callisto into a bear.
She was jealous, right?
Yeah, she was very jealous and she was very upset with Zeus. She felt that it was a huge betrayal, so she thought she would just get rid of Callisto. So Callisto was a bear
Should've
for a
gotten rid
really
of
long
Zeus.
time.
Should have
you gotta
gotten rid
do,
of
yeah.
Zeus.
Yeah. To be honest. So Callisto was a bear for a really long time, wandering around in the forest for a really long time. And remember, Callisto and Zeus had a kid named Arcus. And eventually, Arcus and Callisto found each other, but Arcus didn't know it was his mom. He saw a bear and immediately got scared and pulled out a spear. He was about to defend himself because he's like, oh my gosh, big bear. And Zeus saw this event go down and he was very scared. He didn't want Callisto or his son to hurt each other. So his thought process was to basically create this whirlwind, or some people say that he actually turned Arcus into a bear as well and grabbed them by their tails and spun them around super fast and then flung them into the sky. The whirlwind is also another good one too, which makes sense to me because Zeus is the god of lightning and thunder.
And that stretched their tails out and made them long.
Yes.
I knew there was something weird and my brain couldn't figure out what it was.
There's this
Yes.
old planetarium show called George and Oatmeal Save Santa, and they talk about that story in that one.
Yeah, I have to see that. Like, I'm so confused as to what happens in that show.
George is a snowman, and
Naturally,
Oatmeal
as one is.
a wizard. Or maybe I have it backwards, but there's a wizard and a snowman, and they save Santa.
I already love this.
Right.
It's a great show. It's a kid's show. It's wonderful. We don't show it
Every
anymore.
part of that I just loved. So yeah.
Yeah, but it's a really wonderful show.
The tails are definitely a mystery, but they're a fun one. That's the main reason why there's a long tail for these bears. I did dig around to see if there maybe is an evolutionary pattern, because some people like to believe that since we have a tailbone, we used to have tails. Which
Some people still do.
I don't know
sometimes,
much
right?
about that, but I'm pretty sure that's not entirely true. But I thought maybe the same rule applied, that maybe a long time ago, before humans really evolved into what we are today, maybe bears had a long tail for a specific reason, and then natural selection got rid of it.
That would make them even cuter than they already are. I always want to pet them and I'm not allowed.
Yeah, sadly though, most of my research, I came to a dead end where bears never originally had a long tail. There's at least no evidence of such, so they assume that bears never had a long tail like that.
I remember hearing that, and I was like, I don't know if that's true or not, but like people would teach that as if it was. I think it was just a misconception.
Mm-hmm. It's an interesting debate. You can do. I would recommend doing some personal research about it on your own, talking to the audience here. It's really fascinating, but we're a Constellation crew, so we will be talking about space.
Yeah, you get into a lot of weird stuff when you talk about like the sigil structures and all that.
Right.
Yeah.
But Ursa Minor also is kind of interesting. Some people believe that Ursa Minor, like in the story, is the son of Callisto and Zeus, Arcus, which makes sense to me. Other people associate Ursa Minor and Major. It's not super popular. 2 of the 8 or so nymphs that took care of Zeus when he was on the island Crete, getting away from his father Kronos during the time when he was kids. So the nymphs were taking care of him, and they associate, sometimes they'll say that Ursa Major and Minor are Ida and another one, but there's so many nymphs who took care of Zeus, and it's not very popular. They mostly associate Ursa Major with Callisto. So Callisto is the main story. So I would believe that Ursa Minor is her son, which is super cute.
Why do they turn them into bears, though? Like, why not
Well,
another creature?
I guess to follow the story of Callisto is what I would think, since she was turned into a bear. And I guess because Arcus was terrified of his mom because he didn't know that was his mom.
Mm-hmm.
So I guess maybe Zeus turned his son also into a bear so that they weren't chasing each other like Scorpius and Orion chase each other in the sky because of that myth. He probably wanted to make them both bears so that they wouldn't chase each other, hunt each other, or hurt each other.
And the
At
North
least that's
Star Polaris is the end of the handle of the Little Dipper, or the end of the tail of the little bear here. It's almost like it's pinned up there because it's stationary in the sky. It's always in the north.
Mm-hmm.
All right, so going back to our sky, you can find the Big Dipper really easily, I guess I should say, here in Muncie. Right after sunset, really high in the sky. It's kind of in the north, but really mostly this time of the year, it's almost right over your heads. And then you can use it to find the North Star, Polaris. So if you use these two stars into the bowl of the Big Dipper, connect them with an imaginary line like you're pouring something out of the big spoon here, they'll lead you to the North Star, Polaris, right here. It's the end of the handle of the Little Dipper, right there. Really hard to see. So really here in Muncie, don't expect to see the Little Dipper in full. Even without much light pollution, it's really difficult, but you can definitely spot the North Star, Polaris, right there. All right, crew, any final thoughts before we wrap up tonight? All right, thanks everyone for watching. Next week, we're going to wrap up the entire semester with a really cool, fun constellation crew. We have something really amazing that came to Melanie in like a dream or something planned for you. So make sure to tune in next Friday at 6:30. Then we're gonna have a little bit of a break during the summertime. But thanks for watching tonight, and we'll see you next week. Take care, everyone.
Bye, guys.